Hello and welcome. Today's exercise. So I'm extremely sorry for the delay and that I only published it today, but I guess it's better now than never, right? So today I'm gonna show you how to write a basic service in WCF. This will be a service that uses a SOAP protocol to communicate between nodes, between client and server. And we're gonna use the um, basic tools provided uh, by the .NET Framework. Um, it's pretty important that you know that we're talking about .NET Framework and not .NET Core. .NET Core is a version of the environment that is supported on multiple operating systems, so you can run .NET Core on Linux or OS. Um, but .NET Framework is Windows only, and WCF server is supported only on on .NET Framework. There are some attempts to port it to .NET Core, but they're not officially supported by Microsoft, and we're not going to dive into the details of them. So they may be not complete and generally not as stable as the official framework. So make sure that you actually use .NET Framework. So the important part here is that you know that you actually installed it. It is something that you need to set up. Um, that you need to set up in Visual Studio installer. So I'm using a Visual Studio 19 Community Edition. So if you're using the same one, and you'll probably be using the same one. Sorry for the Polish version. So you need to make sure that you have WCF supported Windows Communication Foundation. You need to have this thing installed. If you don't, then you won't be able to create. So now, first of all, we're gonna add a new project, and our new project will be a WCF service library. So make sure that you actually pick up a service library and not the service. The service will be would be good, and you can use the service in any real project. We're gonna use library because it will show us a little bit more about configure the bindings and this sort of thing. So now we're just gonna call it the WCF service library 1 because why not? As good name as any other. And now next thing we're gonna do is we're gonna go through the contracts that are defined. So we get three files that are automatically generated: iService1, service1, and appconfig. This appconfig is a configuration file, and it mostly is important for services. It's less important for libraries. These bindings are something that is defined by the library anyway. Metadata is important, so but you can override that if you want. So this file is not as important as the other two. iService is the service definition, is the service declaration. So the service interface, or as WCF calls it, a service contract. Service contract is roughly that's roughly what you would call a service in a protobuf file. So this interface is basically a service from protobuf, just written in C# and with WCF syntax. So we define a service that's called iService1, and the service has an operation, or if you like to use the protobuf version, an RPC that is name get data that returns a string and takes an int as an argument, and another operation that can get data using contract as a name, and it takes a composite type as an argument and returns a composite type too. And then we also define a data contract. So in terms of protobuf, that would be a message. It's called composite type, and it has it has two members that are full value. So really, that's nothing complex. It's also pretty similar to what you do in RMI. It's just that instead of extending a remote interface, we annotate it with service contract, and that's the basic difference. Um, so really, that's just a declaration. These things are a little more powerful though, as they do have quite a lot of possible parameters. Like you can define a callback. I'll cover that in the second part of the. You can define session modes. So if you need session or maybe you don't need session. In case of operation contracts, you can also define a lot of things like if it is a one-way operation, can it terminate the service? Is there a replay action? Is there a SOAP action? What's the name of action in the SOAP payload? So it's also quite powerful. We're not gonna cover the Wireshark traces today. That's basically every message you send gets 4 kilobyte overhead of SOAP headers and all the messages around, and that's quite big if the message that you send is like I don't know 4 or 40 bytes. This the overhead is quite significant then. Um, so it's usually better to use SOAP for passing in documents of a bigger size. So that's generally what we prefer these days, the document style communication rather than RPC style. Not everybody. I mean, there are some interfaces that do use RPC, like protobuf is a prime example. But there are also JSON RPC interfaces like the one provided by Slack, for example. Although the RESTful APIs are more. We did cover those. And in case of data members, we can of course change names and maybe add some default values or whether the parameter is required or optional. So that's the service interface. It's straightforward, I guess. And the second thing is the service implementation. And we basically work with it at the same way we do it with we do in Java RMI, which is we just expand this interface and implement the methods. And that's more or less it. Now there is a slight change, so we can add something that's called service behavior. And service behavior is defines some details of our service. For example, whether we want to have concurrency mode. So if we want to support only a single threaded, if the same service is single threaded, and that would mean only one thread can be anywhere inside the service at the same time. So if a function is called, then no other function will be called at the same time. If it's reentrant, it basically means the same as single threaded, but if a thread is suspended because because the service calls another WCF service, and that's important, only another WCF service, then another call may be handled. And the third one, which is multi-threaded instance. So what you need to know is that WCF itself does not provide any thread security. So if you need any synchronization, that's something that you need to do yourself. Another important item in case of in context of this of the multi-threading is the instance context mode. And instance context mode defines whether we create a new service instance per each call session, or do we have a single service and we don't care about and every call is handled by the same instance. All are valid options. You need to make sure that you use the right one. If you pick up a per call, then this thing is basically transient or ephemeral if you prefer, which means that you don't need to care that much about the concurrency. If you have a single one though, then you need to make sure that you actually synchronize all access to data, that all threads will be properly managed. Okay, we do have some original functions. That's basically nothing fancy here. We just get a string from a value and that's it, or some object. So I'm not gonna write anything new here. It's just we're just gonna live with this thing. So we did define the service, but we still need to run it. And to run the service, well, we need to provide a runner, if you will. Our runner will be a new project, and this project will be a console application, a .NET Framework console application. Make sure that you pick .NET Framework and not .NET Core. In most instances of Visual Studio Community Edition, you will also have .NET Core here as an option. Make sure that you pick .NET Framework, because otherwise you won't be able to. Let's continue. Now we have our console app. Now our console app needs a dependency. So let's add the dependency. So it depends on our WCF service library. Because the console application that we'll be writing now is just a runner for the library. There's really nothing fancy, but well, it needs to know what will it run. I mean, technically that's possible to run it via reflection, but much more complex, and we don't. We're just gonna cover the basics, and all that stuff. So next thing we need to do, we need to create an address, and in this case this will be a new URI, HTTP localhost, whatever, let it be 9999 and let it be base. That's the address, and of course not be a dash, it should be then what we need to do is we need to have a service host. Service host is something that we don't have yet, and that's because we didn't have a dependency to service model. So I'm gonna add it. This thing says add a dependency to system service model. I didn't do it. I could do it using this menu, references, add reference, and here assemblies, and here if I go to system service model, or I could wait until the Visual Studio tells me that hey, you actually need this model thing, which is what I. Okay, so now we create this new service host, and this new service host is of type is of the concrete type, which is in our case service. I think it's service. and we need to import the service. So, wow. Service one. We need, and it should be visible on basic. Then we need to add something that's called a binding, which is basically saying that we're gonna use an HTTP protocol. That's quite important because SOAP can also be run on top of TCP or actually even also other protocol. But we're gonna use HTTP. Um, then we're gonna have service endpoint. H add service endpoint, and our service endpoint that we're gonna add is of type iService1. So our endpoint will have to fulfill the contract of iService1, and it will be supported by binding, and the actual endpoint will be called service1, and there's apparently something with that. So maybe we should import it. And then finally, we're gonna add also something that's called the service metadata behavior. And service metadata behavior is a class that defines if the metadata of the service can be obtained during runtime. And in our case, we want it to be obtained because it will make the development a little bit easier. Although in production, you will want to make that you don't have it enabled on production, or at least that you know why you do have it. And then we can on our host we can add a behavior of SMB. Means that a service metadata behavior will be added here. And finally, um, we're gonna start the and then let's wait for some information, and then let's close. And of course, some anything can happen. I can get an exception. So in this case, I'm gonna abort. And we're gonna print out. So let's check if we can run it. And we got an error. You may encounter an error regarding permissions that you cannot bind to this port or something like that. Yeah, something like that. It cannot register. Well, no. So basically, you can get an information that you cannot bind to this port because your security policy doesn't allow that, and in this case, you need to modify the security policy. And you can find um, the exact instruction um, either in the task instruction, or if you don't find it there, you can also Google it up. It's one of the first uh, searches. Okay. Now another thing that we can do is, well, maybe now we should have a client, right? So let's create another. So let's this first, and then let's add a new project. And this project will also be .NET application. Let's go to Comp2 because why not? In this other application, it will be client. Now the client can have something that's called a service reference. This is basically something that is generated from, that is a WSDL file that is used to generate some client-side code. But to be able to do that, it needs a running service to be able to scrap metadata from it. Now, we can have one from testing, or we could start it up here. So we can start it up. So our service library, and then we go to one, and then we go to binaries, and then we go to debug. Oops, here. Why not? Compile again. Debug. Oh yeah, that was here. Let's run the console application. Yeah, and that's the error I was talking about, which means that the HTTP protocol cannot register the address because the process has no access to the namespace. Which sounds a bit weird and scary, but don't worry that much about it. Let's go to the link referred here. So there's quite a bit of explanation why do you need to reserve a namespace for IIS. The important thing is this, which is what do you need to do to, this is the command that you need to run to add the right access. So I'm gonna run it now. Called. You need to run it as an administrator because otherwise you won't have enough rights to modify the username and say. Yeah, so obviously this is wrong now because the SDD because there is no such thing. There is no domain user and the address is incorrect, so I'm using 9999 and the URI I'm using is, I guess, base. Let's verify that with program 999 base. Good. So this is what I'm using, and user is maybe this one. So okay, and now let's run it again. And yeah, I have correct access rights. I can close it, but okay. Since we managed to run the application, now we can go to our client and add something that's called service reference. Yeah, reference. And then we need to have an address. if we used an automatic verification, automatic search, we would find something that's called design time addresses WCF library, which is basically the same set of addresses, but the ones that are available during design time. And if we wanted to use the ones from the running application, we would need to have a localhost base here. Mm, okay, give me a second. And then I get the service that has to operate. This is available because we enabled the HTTP GET for service metadata. If we disable that, we wouldn't have this. Okay, so we add this service reference. You know what? I'm gonna show you what is the result. So I'm gonna go to localhost 9999 base. So we get a service, and if we want a WSDL, we go to this link, and this thing is the WSDL definition for our service. Pretty extensive for two functions, you might say. You would probably be right. And it also has some hard-coded values that you might not like address location or the identity. So make sure that you know what you're doing. Anyway, we already have our service reference here, so we can use that. So funny thing is, this client is generated here automatically under the service reference 1, service 1 client. New service 1 client, I can create it. And I can create it with no arguments because my application config has endpoint address for this exact service. Reference 1, iService 1. So it knows that that it's supposed to use this address. In production, you wouldn't like you won't like that, but you will modify app config. So that's not critical. Usually, it's usually not critical. So what we can do now is we can call get data function with 10 as an argument, and maybe we can console it. That's one C. Maybe I can print it so we can see if everything works. So have our variables. Yeah, already finished running, and now yeah, so it did. So let me add a console here just so that it will wait. Here. Oh yeah, of course. I'm using WCF library as my startup project, and I should have should be using console app. Now it's a little better. After we got oh yeah, I used get data as async. So now we have you entered 10. And you entered 10 is exactly what service 1 from get data. And we can also use get data using contract, but that's, I mean, that's okay. So that's the basic integration. So we managed to um, integrate the service and the client using a simple HTTP binding, one-way binding. And you can also add multiple endpoints to the service here. So you can add here you can we are using only a single endpoint with iService, but if you have another service contract, you can add it also here as another endpoint, and another yeah, you can bind to it with another endpoint here. And here you have this definition. You can extend it. Create another operation contract, say which would be let's say that this one would be one way. Um, One-way operations always return void because the client doesn't wait for and let's call it launch the newt. We can create another operation if we want to. Yeah, we need to apply the changes. And of course, we also need to implement it because right now we've only modified the interface. So we're gonna implement it. And we're not gonna throw the status, but we're gonna just paint something on server line. So the difference between these two functions, between operation that is one way and operation that is not one way, is that this kind of operation can return a value. And when it returns a value, um, the client can can use it. Now, operations that also means that at some point of time when WCF was young, this meant that the operation is synchronous. And synchronous operations are generally um, long running compared to okay, because network calls are long and they take time. They take a lot of time, especially compared to what happens on a local machine. Now, that said, the folks that created WCF understood that you need to be able to support async tasks, and for that we have this is a one-way method, which is basically says this method will not return any value directly. However, even if the value itself doesn't provide any direct value, doesn't mean that we don't want to know anything about it. It will be quite common that we will want to know about some progress or about some intermediate values like we would like to get, for example. And WCF also supports that, but you need to do a few modifications. So first of all, we need to have something that's called a callback. I'm gonna create a callback interface. I'm gonna call it S1, and it's gonna have operation contract that would also be one way because it's just the return value, to return a callback, so we don't want to wait for the callback really in this case. And call it a number of nodes, and it will take an int. Fairly straightforward, I guess. And the second thing that we need to do is we need to tell the client, tell the, well, everybody that we're actually gonna use that, that we're gonna use this callback. We're gonna add a callback contract here, and this will be type of S1 callback. We're gonna have something like then after that I'm gonna create well, that's basically everything that we need to do on the service side. There is next thing that we're gonna need do on the client on the server side. So on the side of the actual binding to the service. So first of all, here we use WSHTTP binding, which is a nice binding, but not the right one for this case. That's because HTTP binding is a one-way binding, and we really need a two-way binding, and the two-way binding is achieved by having a dual HTTP. Dual HTTP binding is a full two-way communication, which means that you can get however many calls you want for the call. You can return, you can call 10 times. You can run the callback 10 times if you want to, and for example with the progress or something like that. Now, that's still not everything, but that's enough for us to compile. And since we managed to compile, we're gonna start it, and it should start with no problem. But our client will not work anymore. And that's because, yeah, in my case, it's just yeah, it's called a timeout, but it's actually means that we're using a different protocol. So the client expects the server to use HTTP binding, and the server uses a two-way binding. So what we need to do is we need to have this connected service here, and we need to refresh the reference. Now we need to refresh the reference, and after a second you'll see that actually it doesn't compile anymore because of this callback that we've added. So now the callback, the service contract defines a callback, which means that any client that uses the service must provide an address that can be called back with the response, or with some progress, or with whatever, but basically there needs to be some context. So we need to provide this context, and to provide this context we're going to create an object that is called an instance context. Of course, import it, and this is a new instance context that takes as an argument an actual callback. So I'm gonna call it S1 impl callback, and I'm gonna create it here. S1 impl callback. And here's the funny part. What I need to override is always call service1 callback. Doesn't matter what's the name in this file. It's called S1 callback here. In the client, this will always be visible as a service1 callback. So I'm gonna implement that. Maybe not with a throwing error, but with some training. Have also right line. Let's just write number. And now we have this IC as an argument here. And then we run it. And we have the answer 10. So finally, we got to the moment when we can launch our nukes. So we're gonna run S1C, launch the nukes. So we entered 10, and on the server side, we have launching, which means that we did call the right service. It's just that the service doesn't call us back. So what we need to do is we need to somehow grab the callback reference. To grab the callback reference on the server side, we need to obtain the instance. And to obtain the instance, we need to use something that's called an operation current context, and then we want to get callback channel. And our callback channel is of type S1 callback. And we're just gonna say that the number of nukes launch is 101. Because why not? So let's now build this thing. I did the subgroups. Let's start again. Now let's run it. And let's run the new one. And on the client, I have response for the first one and from launching the nukes. And I could have 10 responses for launching the nukes as well. This would basically be the same. And I also have launch, which means that the application works as expected. So we do have two-way communication. We could also check that this. You can also check that it actually is async. Now, one thing that you need to be aware of is that WCF itself is pretty old. So this callback mechanism is not the good way if you just want to run a task in an async way. And if you want to run a task in an async way, the proper way to do that is just to run it async. To run it async, you just run S1C S1C get data async. And then you need to have an await here, or maybe not. Or maybe you can have a var b equals that, and then launch the nukes, and then we can have a console write line await b. Now we cannot use await in a void, so I think right. Okay, so that's just some change in the client side. No changes on the server, so let's run the server again. And if you take a look at that, we're gonna have 10 and 15 here. And the nukes weren't actually launched. You have a launching. But apparently something went wrong and we don't have it Interesting. Okay. I know what happened. Let's just do this in a better way. So this one is this way it's synchronized. So oh, did I mess up the service? Okay. On this thing again, and then we do have await B, and then we have launched the new. And we do have launched. Okay, so that's first. So this problem is actually an interesting one. So um, I'm not gonna show you the solution. So but the first person that sends me information on that describes why is this line not executed and why doesn't this context work as expected here gets bonus points for the exercise. So that's it for today. Um, hope that you the task will be slightly easier now. And good luck.